Okay, today is angles and parallel lines. Go ahead and put your date in the upper right-hand corner of your paper. Now, today is fun because this is where you get into the really cool pictures. There's angles everywhere and you're trying to figure out what the measurements of all the different angles are. Today you learn all of the easy ways to figure out those angle measurements. So, we're going to start off with just one definition and we're going to launch into a bunch of different types of angles. So our first definition is going to be transversal. And a transversal is a line that intersects two or more lines at different points. Let me give an example. I'm going to use some parallel lines because today we're talking about parallel lines as well. We know what parallel lines are, so I'm not going to spend time explaining that, but of course those lines that, look like railroad tracks. Okay, so I have a set of parallel lines. I'm going to draw a transversal for those parallel lines. It needs to intersect two or more lines. I have two lines at different points. So I'm going to draw a line right here. This line right here is a transversal. Okay. It intersects at those two separate points. Now you might be sitting there going, well, what's the point of writing down at different points? I mean, they can't very well intersect at the same point, but be careful. You don't need to write this on your paper. I just want to show you quick on another sheet here. If I have two lines, okay, and I'm going to draw a line that intersects at just one other point. We'll notice that it's all intersecting at the same point, right? So this would not be considered a transversal because it's not intersecting at different points. If I drew a line over here, that's just a little bit messy, not that clear to see, but that line right there would be a transversal because it's intersecting at different points. Not that important that you notice that, but just so you have it to think about. Okay. So transversal, a line intersects two or more lines at different points. This line here is my transversal, intersects these two lines at two different points. Moving along. Go ahead and clear that. Okay. So I'm going to go ahead and redraw that parallel set of lines. And I'm going to put in a transversal. And then I want to talk to you a bit about some of these angles that have been created. For example, I first want to talk about corresponding angles. Now, corresponding angles are, and this is a fantastic definition, angles that occupy corresponding positions. Probably not that helpful for us to write that down, but that's the official definition. Angles that occupy corresponding positions. Corresponding angles are just angles that if we were to look at each set, for example, if I was just to pull out that little picture there and this little picture here, they'd be in the same spot. So for example, if I were to look at like this angle right here, it's in the, maybe the upper right hand corner of that, purple box. If I look down at this other set of intersecting lines down here, it's going to be the same spot, okay? Think about inside of those purple boxes, it's in the same spot in both boxes. They're corresponding angles. They're in corresponding positions. Another set of corresponding angles could be right here, right? This angle right here and this angle right here are in the same spot in those sets of angles. So they're corresponding angles. There's actually a whole bunch of corresponding angles. So we've got this angle right here, happens to be the same as this angle right there. And this angle right here is in the same spot as that angle right there. Okay, they're all corresponding angles. Why do we care? Well, because it just so happens that on parallel lines, corresponding angles, or in parallel lines especially, make sure you have that down so you don't think you can apply other places. In parallel lines, or with parallel lines, corresponding angles are congruent. Which is really nice. For example, if I were to flip my page again and draw another quick set of lines here. So if I had a set of lines with a transversal, and the lines were parallel, and I wanted to figure out, if I know that this angle is 45 degrees, for a pair of corresponding angles. So this tells us that this angle, corresponding angle, is going to be the same position. So it's going to come straight down here and find another angle. Yep, that's the same position. You can kind of eyeball it, but then you go, boy, yep, those look like they could possibly be the same. And I could go, that's 45 degrees as well. So corresponding angles, so they're congruent. Another type of angle are alternate interior angles. And alternate interior angles can be a little difficult to identify if we don't pay attention to what those words are actually asking us. So the definition is angles that lie between the two lines on opposite sides of the transversal. The key point there is that the angles lie between the two lines. So I'm not looking up here, and I'm not looking down here. I'm looking for in between the two lines. And they're on opposite sides of the transversal. Well, the transversal is my orange line. So some alternate interior angles could be, if I picked, let's look for an alternate interior angle for this angle. So this is in between the two lines, so it's an interior angle. I want to get an alternate interior, alternate being on opposite sides of the transversal. So it's going to be this angle, and look on the other side of my line here, for one that attaches to the other line, it's going to be that angle. So these two green angles, those are alternate interior angles. And again, alternate interior angles, when we have parallel lines, are congruent. So we know that the measurement of this angle and this angle are going to be the same. And for our final type, we have alternate exterior angles. Easily confused with alternate interior angles, so these are alternate exterior angles. They're actually incredibly similar, but these ones lie outside the two lines. So if I were to go ahead and draw out my parallel lines, and I'm going to throw a transversal on there again, I'm looking for ones that lie outside the two lines. These are not going to be in here. They're not going to be between the two purple lines. They're going to be outside on the top and bottom parts there. I want to find ones that are on opposite sides of the transversal. So I'm going to pick one angle here. I'm looking for its alternate exterior angle. Well, I'm going to look on the outside of its other set. I'm looking for ones that's on the opposite side of the transversal. It's going to be this angle right here. This angle and this angle are congruent, because alternate exterior angles, when dealing with parallel lines, are congruent. If the lines weren't parallel, we wouldn't know much about them, other than that we have a name for them. So alternate exterior angles are right here. There's another set on this pair of lines, of course. I could also look at this angle right here and look for the one that's on the opposite side of the green line, opposite side of the transversal, but still an exterior angle, so it'd be right here. And again, those angles would have the same measurement. We'll do more work with delineating between all these different types in class, but for right now, just make sure you know what a transversal is. Corresponding angles, alternate interior angles, and alternate exterior angles, and that those three are all congruent when you have parallel lines.